Welcome to my class. Today we will learn very interesting concept of set operations, or rather very interesting concept of mathematics, and that is Venn diagrams. We know that visuals have more effect or long lasting effect in our mind. So if instead of numericals, if we can visualize the set operations, so that will be more helpful to understand the concept of set operations. Now first we will learn that what is Venn diagram. Venn diagram is a diagram that represents sets and their logical relationships in terms of geometric figures like rectangles, circles, and sometimes ellipse. In the world of Venn diagrams, we represent a universal set by a rectangle. So here, as we can see, it is a rectangle which in our case represents a universal set. We know the universal set is represented by capital letter E or U. Say in our case the universal set is E, which has the elements from 0 to 12. So in total this universal set has 13 elements. Now suppose we have another set A which has the factors of 12. Factors of 12 means 1 12s are 12. Then we know 2 6 are 12. Then we also know 3 4s are 12. So what are the factors of 12? 1 2 3 4 6 12. So set A has 6 elements. In Venn diagram, apart from universal set, all other sets are represented in terms of circle. As we can see here, a circle which is shaded in white. So this rectangle represents our universal set which has 13 elements, and this circle represents our set A which has 6 elements. Now sometimes we represent the elements inside that circle by dots. So since it has 6 elements, set A, so here we can represent those 6 elements by 6 dots, and sometimes or mostly we represent the elements if needed by their real values. So if set A has 6 elements and their values are this, then inside that circle which is set A, we can this way represent the values which are 1 2 3 4 6 and 12. And apart from these 6 values, set universal set has also 7 more values, because universal set has values from 0 to 12, in total 13 elements, and set A has 6 elements which is also within 1 to 12. So apart from these 6 elements, this universal set has 7 more elements. So rest 7 elements we can represent this way: 0, then we have 1 2 3 4 here, so 5, then we have 6 here, so 7, then maybe here 8 9 10 11. So in total here we have 4 and 7 elements, and 7 plus 6 elements are 13. In total 13 elements that this universal set has. And we know this set A here is a subset of this universal set. Next we will see how to represent subset or multiple subsets using Venn diagrams. So here this rectangle represents universal set which is E, and again if we take that this universal set has values from 0 to 12, so this E universal set is a finite set which has 13 elements. Now here we have another set which we name as A, and if we assume that A is a set which has all the factors of 12, so we have just now seen that it has 6 elements, so it will be 1, then 2, then 3, 4, 6 and 12. So set A has 6 elements. Now suppose if we take another set B, which has all the even factors of 12. Now here we have 6 factors of 12. Among them we have 4 factors, 2 4 6 12, which are even in nature, and 1 3, these 2 factors are odd factor. So from this list we are, or from this set we are creating another set which has only the even factors of 12. So set B will have 2 4 6 and 12. So can't we say that B has all the set A has all the elements of B, and along with that it has few more or two more elements. So set B here is a subset of set A. Now suppose if we consider another set which is set C, and this set has only the factors of 12 which are multiple of 3. So among these four elements which are even factors of 12, 6 and 12 are two such factors which are multiples of 3. So here set C will have two elements which will be 6 and 12. So how we are creating subsets? So here initially the universal set has in total 13 elements which starts from 0 and ends at 12. Now we are creating another set, we are considering another set which has only the factors of 12. So there we have seen that we have only 6 elements, and those 6 elements are part of E also. So A here is a subset of E. Now we are creating another set which has only the even factors of 12. So here we have even plus odd, in total 6 elements, but here when we are considering only the even factors, here we have only 4 elements. But all these 4 elements are also, they also belong to A. So B is a subset of A which is subset of E. Now we have taken another set which has only those even factors which are multiples of 3. So from this 4 elements, now we have taken only 2 elements, 6 and 12, which are multiples of 3. So here we have only 2 elements, and those 2 elements belong to set B also. So what we can see, what we can say here, that C is a subset of B, which is a subset of A, which is a subset of E. Now in the Venn diagram, how we can represent that? Here E is the universal set, so that is represented by the rectangle, and always universal set will be represented by rectangle. Then A is the subset of E, so A has been here represented by a circle within that rectangle. Now what we have seen here, that B is a subset of A, so here B will be another circle which will be inside circle A. Now we have seen that C is another set which is a subset of B, so that we will represent by different diagrams. So first universal set E, then we will have a subset of P which is A, then we will have a subset of A which is B, so this will be our A and this is B, then we will have a subset of B which is C. So this is how we represent subsets using Venn diagram. Next we will see that how to represent complement of a set using Venn diagram. So here first we will represent a universal set which again we will name as E, and that may have any number of elements or any type of elements. Now we will represent another set which we name as set A. Now suppose if we take again the same example where universal set A has the digits from 0 to 12, and set A has only the factors of 12, so 1, 2, 3, 4, 6 and 12. That means here it will have 1, 2, 3, 4, 6 and 12, and apart from this 6 elements, the other 7 or rest 7 elements, it will be 0, 5, then we will have 7, then 8, 9, 10 and 11. So the complement of a set, so if we take the set A, if we consider this set A, then the complement of A will have which elements? The other 7 elements. That means 0, 5, 7, 8, 9, 10 and 11. And where these 7 elements reside, they reside or they belong to this blue shaded area. So in the Venn diagram, this blue shaded area is the complement of this set A. I hope you have understood clearly this concept. Next we will understand the concept of union operation of two sets. So here first we will take the universal set, and that will be represented by E. Then we will take a set which is definitely a subset of E, and that we will name as A, and we are performing here union operation between two sets. This is another set, set B, and this time we have considered these two sets as joint sets, so they are overlapping. So the when we will perform union operation, we know that union operation is what? The addition of two sets. So it will, the elements of the resultant set, either they will belong to set A or the first set, or they will belong to set B. So when we form the resultant set of this union operation, first we will consider all the elements of first set, and then we consider all the elements of set B, but provided if there are any common elements, then we don't repeat those elements. So in the Venn diagram, how it will be represented? It will be represented first by set A. So this green shaded area or this green shaded circle, and then we will consider the set B, which is also this green shaded area of this circle. And this is the overlap portion which has all the common elements between A and B. So in the Venn diagram, this whole green shaded area is the result of union operation between set A and set B. Next we will see how we can represent the result of intersection operation between two sets. So here again, this is our universal set, which is E. Then we have this set A, and then we have this set B. And intersection is what? Intersection has the resultant of that intersection operation. That new set has all the common elements between those two sets. We know that. So here basically intersection in the Venn diagram will be only the overlap portions between those two sets. That means this portion. So this is the portion which is the common or which is overlapped between A and B. So in the Venn diagram, this represents, this shaded portion represents the result of intersection operation. Next we will see how we can represent the difference operation between two sets. So again, first we will represent the universal set, and with respect to that we will represent two more sets between which we will perform the difference operation. Now next we will take two more sets to perform the difference operation. So say this is our set A and this is our set B. So first we will perform the difference operation between A and B, and then next we will perform the difference operation between B and A. So again, in the second case, we will take the universal set, which is E again, and with respect to that, again we will represent two sets A and B. So this is our A set and this is our B set. Now when we will be performing A minus B, the resultant set will have the elements which will belong to A, but they will not belong to B. That's what we understand by difference operation. So if it is A minus B, then the elements of A we will consider which only belong to A but they don't belong to B. So in the Venn diagram, this will like this. So this shaded portion, this red which is shaded in red, they have all the elements which only belong to A but they don't belong to B, because if we consider these elements also which we have here in under set A, they will also be part of, or they will also belong to B, because this is the overlapped or common portion. So we should not consider this portion. We will consider only that portion of A which only belongs to A. So similarly, when we will perform difference operation between B and A, so here we will consider only those elements of B which only belong to B but they don't belong to A. That means, I hope you have already understood that how it will look in the Venn diagram. This will look like this. So this shaded portion which is shaded again in red, these are the elements where under this shaded portion whatever elements we have, they will only belong to B. But if we have any elements here, or all the elements that we will have here in this portion, which is the common portion or overlap portion, since they also belong to A, so we will not consider these elements. So in the Venn diagram, this shaded portion will be the result of B minus A. Next, we will have the idea of joint sets and disjoint sets, means overlap sets and non-overlap sets using Venn diagram. So it's easy. Again, we will have universal set. We will represent that first, and with respect to that, we will represent two more sets which we will take as joint sets. So this is our set A, which is subset of E, and this is our set B, which is also subset of E. And since they have overlap portion here, as we can see, so that means they are joint sets, because we know in case of joint sets, if we perform intersection operation, then the resultant set will have at least one element, so that resultant set will never be an empty set. So there will be at least one element, so there will be a minimum overlap portion between these two sets. So this is the concept of joint set in Venn diagram or using Venn diagram. Now we will see the concept of disjoint sets. So we know, we have already learned that in case of disjoint sets, if we perform intersection, then there will be no common element. So that means the result of intersection will be an empty set. So in the Venn diagram, they will like this. So this is our universal set, this is our set A, and this is our set B, and there will be no overlapped portion. So this is the concept of disjoint sets. Next, we will perform some operations on disjoint sets. So here again, we will take a universal set which will be represented by rectangle. So far we have already learned that. And then we will have a set which is a subset of universal set. So this is our E, this is A, and then we will have another set which is again a subset of E, and this is set B. So this is what here we, by looking at this shaded portion which is shaded in yellow, we can understand this is basically the operation, union operation between A and B. And union operation includes all the elements of both the sets, and if they have any common elements, then we don't repeat them. But since these two sets A and B are disjoint sets, so here there will be no common elements, so we will consider all the elements of A and all the elements of B. That's why here the set A has been shaded in yellow, the whole circle or whole set has been shaded in yellow, and the whole set B or whole circle has been shaded in yellow. So these two circles which are shaded in yellow, this is the result of union operation between these two disjoint sets A and B in terms of Venn diagram. Next, we will see the intersection operation between set A and B. So again, universal set E, and then we will have set A, and then we will have set B. Since these two sets are disjoint sets, so there will be no common element between them, and since there is no common element between these two disjoint sets, that's why they have not been shaded, and or you can say they have been shaded in white. This white color represents that they don't have any common element, or in the resultant set is empty set. Next, we will perform difference operation between A and B which are disjoint. So again, first the universal set, then set A and set B. So this is our universal set. This time this will be our A set, and this will be our B set. So here first we are performing difference operation between A and B. So the difference operation between A and B here means we will consider all the elements of A which don't belong to B, and since they are disjoint sets, so here all the elements of set A will be the result of difference operation. Now next we will perform the difference operation between B and A. So first again we will have the universal set, then we will have set A, and then set B. So since here we are performing difference operation between B and A, so here we will consider all the elements of B which only belong to B but they don't belong to A, and since they are disjoint, so here the result will be all the elements of B only. Next, we will perform the same operations, union, intersection, difference, on subsets. So first we will have the universal set E, then we will have a subset of E which is A, then we will have another subset which is a subset of A as well as E, because A itself is subset of E, so B set, if it is a subset of A, that signifies that this is also subset of E. Now first we will perform union operation between A and B. So union operation between A and B means we will include all the elements of A and all the elements of B, but if there is at least one common element, then we will not repeat that. But since B is a subset of A, so all the elements of B are the elements of A also. So when we will perform union operation, then if we consider all the elements of A, then that will be sufficient, because that also covers all the elements of B as well. So this A circle or set A is the result of this union operation or union operation between this subset. Now next we will perform intersection operation between same subsets A and B. So first we will again draw the universal set E, then we will draw A, and then we will draw B. So this is A, which is subset of E, this is B, which is subset of A as well as subset of E. Now since we are performing here intersection, and intersection means only the common elements between those two sets. So between A and B, since B is subset of A and all the elements of B are common to A also, so when we are performing intersection, then all the elements of B will be the result of intersection between these two sets. So that means this shaded area or this circle B or set B will be the result of intersection operation between these subsets of E. Next we will see how we can represent the difference operation between two subsets of universal set or maybe some other set. So again we have taken first the superset, which in our case is the universal set, and then we have taken two subsets of E. So here this circle first and then again another circle, and the third set, as we have performed already, the third set is the subset of the second set and which again subset of the first set. So this is our A and this is our B, and what we are performing here, the difference between A and B. And what we know that when we will perform difference between A and B, so we will consider only those elements of A or only those elements which belong to A only, but they don't belong to B. So this shaded area, which is shaded in green, under that area whatever elements we have, we will consider only those elements, because here the subset B, the elements that it has, they are also part of A, but we will not consider those elements. So we will not consider this subset B or this circle, only this shaded area, with this green shaded area we will be considering, and that will be the result of this difference operation. Now we will perform the difference between B and A. So again we will have the superset, which is E, and then we will have two subsets A and B. So here B, the difference is between B and A, that means we will consider the elements of B which only belong to B but they don't belong to A. But since B is a subset of A, so B does not have any such element which doesn't belong to A, because all the elements of B, since it is a subset of A, all the elements of B are the elements of A also. So when we will perform B minus A, in that resultant subset, in that resultant set we will not have any elements, so that resultant set will be an empty set, and that's why we have not shaded any portion of this A and B. This represents that we don't have any element in that resultant set, that is an empty set. Next we will perform some operations on joint sets. We have already performed operations on disjoint set. So for joint sets also we have already seen the union, intersection and difference operation. So here we will be seeing two more special operations on joint set. So here first we will take the universal set or the superset. So the operation that we will perform here is, first we will perform the union operation between two sets which are A and B, and then we will take the complement of that union operation. So first we will take the universal set, and definitely we will represent set A and B. So since this time they are joint sets, so there will be at least some overlap portion. So this is our suppose A set and this is our B set and this is the overlapped portion. So what will be the result of union between A and B? All the elements of A, that means whole A circle, and then all the elements of B, that means whole B circle, and definitely it will also include the overlap portion. So what has been shaded here in white, this is the result of union operation. So this is the result of union, and then we are taking the complement of that union operation. That means within that universal set, now if we perform the complement, so it will include the elements which are not part of this union operation, or not part of these white shaded circles. So that means which is shaded in blue, the rest of the part of that universal set, that will be the complement of this union operation. Now next we will perform, first we will perform the intersection operation and then we will take the complement of that. So first we will draw the universal set, then we will draw both the sets A and B, and since again these two are joint sets, so there will be a minimum overlap portion. So this is the overlap portion. Now what we are doing, we are first performing intersection operation. So and then we are performing the complement of that. So intersection operation means this green shaded area, this is the overlap portion between A and B. So this is the result of intersection. In the Venn diagram, this green shaded area is the result of intersection, and then we will take the complement of that. That means we will consider now the rest of the portion other than this green shaded area. That means whatever is here shaded in white, that is the complement of this intersection operation. So between A and B, this is intersection, and apart from this green shaded area, the rest of the portion is the complement of that intersection operation. Now we will perform some operations on 3 sets. So far we have performed all these operations on 2 sets. Now we will perform on 3 sets and we will represent using Venn diagrams. So first what we will do, first we will perform definitely union operation. So we have 3 sets A, B and C. Now first we will take the universal set E, and then this is set A, then this is set B, and then this is our set C. So the whole shaded area which is shaded in this color, so this is the result of union. Now we will see what will be the result of intersection between A, B and C and how we can represent using Venn diagram. So first again the universal set, and then we will have set A, then we will draw set B, and then we will draw set C. Now here we are performing intersection between 3 sets. So definitely the overlap portion between these 3 circles will be the result of intersection. So if we further draw, then this much area is the overlap portion or the common portion between all the sets A, B and C. So this is the result of intersection. Other than this area, this portion is common between A and B, but this portion is not common with C also. This portion is common between B and C, but this is not common with A, and this portion is common between A and C. Only this much portion is common between A, B and C. I hope you have gained a good knowledge of Venn diagrams, which will help you a lot in future. In the next class, we will be learning something new. Till then, stay safe and stay healthy. Thank you.